Hey guys, this is Eureka John at Eureka Street Crypto Hub, coming to you from Leander, Texas at 1:59 p.m. January 2nd, 2021. It has been a really interesting ride going on with the crypto world and Bitcoin over the past few days. Right now, as I speak, Bitcoin, I believe, is at $33,000, just over it. It's been a meteoric rise this morning. Hey, there you are, from 29,000 to 30 to 31, 32, now $33,000 on Bitcoin. So this will be interesting to see. Okay, today we are going to talk about Zilliqa. I will do another broadcast later on to talk about the rest of the market. But for right now, I wanted to do a dedicated broadcast about Zilliqa. I've been trying to study up on this blockchain for a few days now, and just getting into the thick of it and learning more and more as I go along. And this is a really interesting project, and I think it has a lot of future potential, so I wanted to talk about it. Okay, so here we go. Got my cover here. Zilliqa, power in shards. What does that mean? Here we go. Let's go ahead and close this cover image out, and we'll take a look at the Zilliqa website. The first of its kind, Zilliqa is the first public blockchain built entirely on sharded architecture. What is a shard? Zilliqa is scalable, secure, and decentralized. Sounds like what Ethereum is trying to achieve as well. Those three things right there are kind of a trifecta of goals of any type of Ethereum-esque type of platform. Scalable, secure, and decentralized are all three really hard to accomplish. So all these blockchain projects right now, they are all trying to achieve those three goals, and it's pretty interesting. So what is sharding? Sharding, in a way, is a way to take all the transactions on the blocks and the nodes that perform those transactions and validations, and to break them up into shards in order to widen the traffic highway in a way. Sharding has been around for quite a bit, quite a long time here. Let me see here. The etymology of the word sharding, I found this pretty interesting. I love Wikipedia. I mean, it's one of the best inventions ever. I mean, I remember the days of Encarta back in the 90s, but that tells you how old I am, early 90s. And then before that, I actually had an actual encyclopedia. And look on my bookshelf there. I have actual encyclopedias right here from 1956. It's pretty fun to open those up and look at some of the language and how some approaches to certain topics have changed and the things that they are able to address back in the 1950s that they don't really talk about now. Anyway, Richard Garriott, creator of Ultima Online, recollects the term sharding being coined during production phase when they attempted to create a self-regulatory virtual ecology system whereby players may leverage new internet access, a revolutionary technology at the time, to interact and harvest in-game resources. Let's see, and he goes on to talk about that a little bit, and let's see here. So Garriott's production team attempted to mitigate an issue where, here we go. Although the virtual ecology functioned as intended during in-house testing, its natural balance failed almost instantaneously due to players killing off every living wildlife across the playable area faster than the spawning system could operate. Garriott's production team attempted to mitigate this issue by separating the global player base into separate sessions and rewriting part of Ultima Online's fictional connection to the end of Ultima 1, The First Age of Darkness, where the defeat of its antagonist Mondain was also led to the creation of multiverse shards. This modification provided Garriott's team with a fictional basis needed to justify creating copies of the virtual environment. However, the game's sharp rise to critical acclaim also meant that the new multiverse virtual ecology system was quickly overwhelmed as well. And after several months of testing, Garriott's team decided to abandon the feature altogether and strip the game of its functionality. Today, the term shard refers to the deployment and use of redundant hardware across database systems. So sharding has been around since the 90s. Here we go. Up here, I found this, and then I went to Ultima Online and went down that rabbit hole. An artificial life engine was supposed to be implemented into the game. A preview announced that ecological events of the game would affect animal behavior, potentially creating new adventure possibilities in an organic manner. However, this feature never made it beyond the game's beta stage. We thought it was fantastic, and then we spent an enormous amount of time and effort on it, but what happened was that the players went in and just killed everything so fast that the game couldn't spawn them fast enough to make the simulation even begin. And so that this thing we'd spent all this time on, literally no one ever noticed, ever, and we eventually just ripped it out of the game, with some sadness. And I had to go take a look at this game. Let's see here. Oh, no. Yeah, here it is. Ultima Online, and then here we go. You get to select your shard in history. In Ultima History, a powerful artifact known as the Gem of Immortality was shattered into many shards. These shards make up the universe of Ultima Online, with each one being represented by a different server. So this can kind of give you an idea of where sharding came from. It came from the idea of splitting a database horizontally. A database shard, or simply a shard, is a horizontal partition of data in a database or search engine. Each shard is held on a separate database server instance to spread load. Some data within a database remains present in all shards, but some appears only in a single shard. So, an example of somebody doing a search, and they have East Coast customers and West Coast customers, and they could split the database within the umbrella of one specific product, but split them into East Coast and West Coast version the customers of that specific product, and then put them on different servers to make searchability more lightweight. Of course, there's a lot more communication that has to go on between those, and that's a whole other issue with sharding, but allows scalability to happen. And this is kind of, in a way, what Zilliqa is trying to achieve, because the Ethereum blocks, what was happening in blockchains is these blocks, you would have to increase the block size to allow more transactions to get done on one block, and that's their attempt to scale. Well, you can't really scale too much by increasing the block size, because then it becomes too heavy, and everything clogs up, and it's just the problem that Ethereum has been having is the traffic on Ethereum, and it started with CryptoKitties, I believe. The popularity of that game brought a bunch of traffic to Ethereum and clogged it up. And then the way Ethereum works is the more traffic there is, the higher the gas prices are, because everybody's trying to increase the amount of gas they pay to get their transaction through first. So what Zilliqa is trying to do is provide a solution to this, and they do it by sharding. So let's see, here we go. Let's go into, take a quick look at Zilliqa. So Zilliqa is scalable, solves the prevailing issue of scalability using its own unique sharding technique, which allows the blockchain to scale in a linear fashion as the network grows in size. Its ability to handle a large volume of transactions makes it suitable to meet enterprise needs. It's secure. In addition to using well-studied and established mechanisms to validate transactions, Zilliqa is powered by the first peer-reviewed and safe-by-design smart contract called Scilla. Language called Scilla. The programming language addresses several known security variables that are still prevalent in other languages. And decentralized. Utilizing its subdivided network, Zilliqa is able to process transactions in a decentralized manner without a trusted coordinator. Its network architecture allows the platform to remain decentralized as it continues to grow and expand. So I talked about the example about the database splitting off into East Coast and West Coast customers by product, but that database is still centralized. And what blockchain technology does and what all the nodes do, that decentralizes everything. However, when you're decentralized, you have a lot of communication needs, and that is also needs to be addressed here. And then you have security concerns. So it's kind of that trifecta. What I'm talking about has to be scalable, but still has to be secure, and it has to be decentralized. And if you can, it's easy to get really good at one of those, but it's hard to get good at all three of those. And that's what a lot of these projects are trying to achieve, is to get fully stable in all three of these aspects. Um, so let's see. Let's go into here. Zilliqa scales with a network size. By implementing network sharding, Zilliqa is able to divide the network into multiple groups. So, for instance, if 6 shards, each with 600 nodes, processes transactions individually, then all the shards will collectively be able to process around 2,828 transactions per second, TPS, transaction per second. It reminds me of the movie, what was that? Bill Lumberg, Office Space. You know, yeah. Do you have the TPS reports? Yeah, great. If you could just come in on Saturday, that'd be great. Yeah. What about those TPS reports? So this now I'm putting it all together. Yeah. The main character, Ron Livingston. I can't remember the character's name, but that Bill Lundberg would come to him and ask him about the TPS reports. Was he working on Fortran and working on the was is Initech a credit card processing company software credit card processing software company? Now that they're working on TPS reports, maybe so. Maybe that's what he was doing by updating the database for the Y2K software, so all the TPS reports don't get screwed up. Anyway, it's all making sense now. Got sidetracked. So Zilliqa scales easily with this sharding. So what the nodes do is it shards the blockchain, and each shard is 600 nodes. So the node, if you recall from other types of other studies or other broadcasts that I've done, the node is where the transactions take place and are verified. And if you have 600 nodes, each doing a little piece of the transaction, and then they put it all together in the block after all those transactions are done, they're spread out and they can all take care of a little piece instead of it all having to be done one by one node, trying to create a block itself. And then, so that's kind of how sharding is more efficient, because it spreads the work out amongst all the different shards, and the gas fees are a lot lower. Scalability or lack thereof in legacy blockchain has a direct impact on the transaction fees to be paid to the network. Spikes in fees are correlated with network congestion and transaction backlogs, like what I was talking about with Ethereum. I mean, the other day I was on MetaMask and I was trying to do a trade, and this was during the middle of the day, like 3 days ago. They were trying to charge me $45 just to do a swap on Ethereum from Ethereum on MetaMask from Ethereum. I think I was trying to buy Cell tokens, and it was $45. I was just like, no way, I'm paying $45 to do this in gas, to do this transaction. So if I were on the Zilliqa blockchain, it would probably have been a lot less and a lot faster to do that trade. The fee market in legacy chains can push the costs to as high as a few dollars, $45. I mean, that's a Chili's meal right there. Due to its scaling ability, fees on Zilliqa are extremely low, even allowing micropayments to be processed. So you could even process 5 cents if you wanted to. Or in gaming, there's all types of little 99-cent transactions. You know, you buying gold and buying skins and buying all types of stuff. So lots of applications. One block is all it takes. One of the biggest issues with Bitcoin and Ethereum blockchains is that each transaction needs several confirmations for it to be considered valid. Confirmations come in the form of new blocks. Thanks to Zilliqa's consensus protocol, once a transaction gets processed by the network, it becomes final, and hence no confirmation is required. So Bitcoin, I know, takes 6 confirmations in order for the block to be valid. So that can take approximately an hour, it says here. I don't think it's ever taken me an hour to get a Bitcoin transaction through, but it can. It depends on the traffic. Ethereum, roughly 6 minutes. I've even seen it take longer, and this says about 40 seconds to 2 minutes, which is pretty good. And then down here in the website, it goes through the whole design story, the part 1, sharding, part 2, consensus protocol, and part 3, efficient consensus. I've kind of brought it out here. If you really want to get technical, go to part three, but parts one and two explain it pretty well. Um, they demonstrate here crowdfunding, smart contract, and Skilla. Skilla's their language. It's like the equivalent of Solidity in Ethereum. It's a smart contract language. A lot of the vulnerabilities and what makes Zilliqa very secure is the Skilla language is made for Zilliqa and for the Zilliqa blockchain in mind and for smart contract applications in mind, and they address a lot of the known attack points that people have found in Solidity and other types of smart contracting languages. So Skilla is designed with this in mind, and it's made to attack a lot of these issues at the language level, which is really good, really interesting when you get into it. But this is just an overview, so I'm not going to go deep within it. But they make a point. So, in the field of traditional software development, the usual purpose of designing a new program language is to make certain tasks easier for developers. For instance, with the advent of object-oriented programming languages, it became easier to reuse parts of a code, so you could make basically code modules and plug them in wherever you need them. With scripting languages such as Python, it became easier to automate the execution of system-level tasks. Languages such as Java made it easier to manage memory, and Go has made it easier to handle threads and so on. Smart contract languages, despite being domain specific, still share some of the design principles of traditional programming languages. However, there are two particular aspects where they differ from traditional counterparts. Due to the immutable nature of blockchains, they cannot be updated. If a bug in a software, smart contracts cannot be updated in most languages. If a bug in a software is found, it is possible to fix it and release a new version. The impossibility to update contracts is a serious limitation considering the fact that smart contract platforms drive an extremely large blockchain-based economy. And then smart contracts differ from traditional programs in the sense that they have a gas mechanism to pay for computational costs. I believe Skilla allows you to update it, and then I believe it has a lower gas cost here. So, it just goes down through and gives you specific examples and types of, issues that happen with Ethereum and how the Skilla language is different and circumvents those types of issues. So the conclusion is smart contracts as we see them are not very complex, and yet a simple bug may lead to great financial losses. And then because of the fact that smart contracts run in a Byzantine environment, and I'll explain that here in a second, it is difficult for a smart contract developer to reason about the correctness and safety of a smart contract as attacks become hard to predict at deployment stage. With this in mind, we certainly need to define a better and safer smart contract language that can ease developers' tasks in reasoning about a contract and is principled and structured in a way that can help eliminate certain bugs directly at the language level and make contracts inherently safer. What do we mean by safety of smart contracts? What are safety properties that we want to guarantee, and how should the language be designed in order to ensure those properties? How should the separation between the communication and computation aspects be defined in the language? So these are the things that they're trying to address with the Skilla smart contract language. And then the next article here, it goes through the different phases of it. And it talks about the Byzantine fault tolerance consensus mechanism. I do want to show you guys what they mean by the Byzantine fault tolerance, and I will here in a second, but I do want to say that the Zilliqa blockchain is divided into two different parts. It's a proof of work mining blockchain for identification purposes only, and then it goes into a hybrid Byzantine fault tolerance type of mechanism for consensus in order to validate the transactions, and that's where the Zilliqa token is earned by the miners and the nodes. So here we go in the white paper. Yes, I do sometimes read white papers, even though I can only understand maybe about 2/3 if I'm lucky of it. But anyway, part C here, the Zilliqa protocol introduces two types of blocks and thereby two blockchains: transaction blocks and directory service blocks, TX blocks and DS blocks. TX blocks contains the transactions sent by users, while DS blocks contains metadata about the miners who participate in the consensus protocol. So what happens is, first, somebody who wants to create a node for the network, and the node is where all the transaction verifications happen and provide security. And the more nodes there are on a network, the more decentralized it is, and therefore less centralized and more secure and more democratic. I got my LaCroix today. So what happens is somebody creates a node, and first the node for security and to prevent Sybil attacks. And a Sybil attack is an attack where somebody creates a lot of multiple identities and tries to gain an advantage in a node to force decisions to work in their favor, and can therefore steal money from a blockchain, or steer the blockchain in a direction that it's not intended to go, and they're called malicious actors. So what the proof of work mechanism in this does is it verifies the identity by solving the hashes of the computer of the node. So it verifies the identity of a node, making sure it's a legitimate node and not a malicious actor. And then once that node is identified, then it can be assigned to a shard of 600 nodes. And so once that node is assigned to a shard, then while in that shard, it can do the transaction blocks, and that's where the blockchain is actually formed and the transactions are done, and the miner obviously gets the reward after that. So that's kind of how it does. It's two different blockchains, and there's two different processes, and then I guess every 100 transactions, I think they revert back to proof of work to make sure that every single node in the shard is still legit and not a malicious actor. So it's another security mechanism here. I did have to look up what Byzantine fault tolerance is. I had to look up what Sybil attacks are, 51% attacks, double spending. This is a great article on bitorb.com. Just, I guess, Google bitorb and then double spending explained, Sybil attack. But here we go. Byzantine fault tolerance. I've been seeing this term being thrown around quite a bit, and the Byzantine general's problem here, the meaning of Byzantine fault tolerance is, in the Byzantine general's problem, a fortress needs to be conquered. For the fortress invasion to be successful, all the platoons led by each captain of the general's army must attack simultaneously. So this would be the nodes. How does the general guarantee that all captains receive the same message to attack at the same time? How does the general guarantee that the messenger is not captured by the enemy and alters the message that is sent to the captain? How does the general guarantee that the captains themselves are not traitors? The Byzantine general's problem highlights the challenges obtaining a unified set of records across a distributed ledger, whereby it is 1. Difficult to synchronize data across a large number of nodes in the network, and then 2. Protect the data in the network from being corrupted due to a malicious node. To achieve consensus across all the nodes regarding the right block of data to add to the blockchain, we can either use central validation or a random consensus model. And then it goes in and explains that, and then it explains double spending. Attackers of the network are unable to steal money from the blockchain due to the asymmetric cryptography protecting each wallet's private keys. Neither are they able to perform denial of service attacks for extended periods of time on the blockchain, and i.e. the designated time for a block to be created is usually set to 10 minutes or less. So actors in control of the nodes, malicious nodes, can perform double spending. Double spending occurs as an attacker is able to change a transaction in the distributed ledger. So what happens is you'll have block 11 here, and then block 12, and then you'll have the legitimate transaction of minus 0.1 Bitcoin, and then you'll have the malicious actor come in and pull that back out and then say, and then no Bitcoin was ever paid, but they'll say that is the legit transaction. And then, the way blockchain works, one has to follow after the other, but the malicious actor has come in, and this is where the proof of work mechanism on the Zilliqa chain comes in. They do the proof of work to verify identity first to make sure some malicious node can't come in and falsify the transaction value on this block, because thereafter you have this fork in the blockchain with all these incorrect accounts on here because this one block over here got messed up and they did a double spend. And then the longer that wrong fork gets, then this legit fork here gets orphaned and dropped off, and then you have the network failure right there, basically, of everything being completely incorrect and somebody having been able to steal money off the blockchain. And that's not good. So you want to try to prevent that. And the way Zilliqa is set up and its security and the Scilla language, it helps to prevent these types of 51% and Sybil attacks. A Sybil attack is where a bunch of nodes with incorrect identity come in and overtake the network, and a 51% attack is where those malicious nodes use more than 51% of the computing power to alter the blockchain transactions in their favor and not in the favor of everybody else on the blockchain. And so therefore they steal the funds or misdirect the blockchain in a bad way. So Zilliqa prevents this by their proof of work and then their Byzantine fault tolerance consensus mechanism. And so those are two of the main things that help the security on there. So you have the scalability with the sharding, and then you have the security with the hybrid blockchain design. And then what was the third one? And then you have it being decentralized with them allowing 600 nodes per shard, which really creates a lot of decentralization in the system. So it's pretty interesting stuff. I think they have it down pretty well. So far, everything that I've seen in the Zilliqa community and all the applications being built on it. Okay, Zilliqa doesn't have as many applications, and they're not the first. Okay, they're the first mover for sharding, which gives them that advantage. Because Ethereum 2.0 is working on sharding for their own platform as well, but they're behind Zilliqa. So Zilliqa has the advantage of being the first mover for sharding. However, Ethereum has the advantage of the larger network effects, and more people are using Ethereum. Lots of applications and projects are built on Ethereum. So could be kind of a VHS versus Betamax type of deal. Zilliqa does the sharding and the scalability and the speed a lot better than Ethereum, which was kind of the Betamax of the 80s. It had the better quality video and all that stuff. But VHS was more widely used, it had more of the money behind it, and it had the network effect, which is Ethereum right now. It'll be interesting to see if it pans out. Some people have said that I've asked, and I've been searching for it online here. I found it on something on Reddit. Will Ethereum 2.0 make Zilliqa obsolete? I couldn't really find any really good answers. This guy here says doubtful. There are advantages to each network that suit different tokens for different reasons. Think of them like operating systems for programming money. Everyone doesn't only use Windows or Mac because they are different for a reason. Ethereum won't satisfy every need, just like Zilliqa won't either. There's plenty of room in the crypto space for both. Ethereum has had a lot more time to build a following and grow their product. Subsequently, Zilliqa has bypassed a lot of mistakes that Ethereum ran into along the way and started out with a better product. Best advice I can give you is to do hundreds of hours of research on both to make an educated decision. Even if you're certain about one or the other, always have a contingency plan for your other investments. If you're always prepared for either direction, then you can't lose no matter what happens. I think that's good advice. Again, not financial advisor. I don't even know why I have to say that because, definitely not financial advisor. But I like both. I mean, I have Ethereum and I have Zilliqa. I'm staking on Zilliqa, which I'll get into all that staking and wallet here in a second. So just do both, and I do believe that there's a lot of people say that there's Ethereum killers, Cardano and EOS and Zilliqa. I don't think that there's an Ethereum killer. I think there's plenty of room with all this institution money coming in for everybody. There's going to be so many niches. I mean, this is like the internet. This is the new internet. It's the internet of money, and there's going to be plenty of room because there's a lot of money in the world. So just think about that. Instead of all this tribalism going on, just get a little bit of everything. Study everything, like I do. I'm the jackass of all trades. So I really love studying all these different projects, and everything has their own unique niche and their problem that they're trying to solve. It will suck when the day comes when basically the Google of blockchain technology and cryptocurrency comes in and just sucks in all these different unique projects and just takes everything over and puts it under one umbrella. I love this unique tribalism going on, and everybody kind of gravitating towards certain aspects that they like about it. But anyway, let's talk about the Zilliqa staking. You can stake your Zilliqa. I have my Zilliqa on Atomic Wallet, and on Atomic Wallet right now, it varies the staking percentage, but my Atomic Wallet goes with 16% right now. It was at 17%, and then no, it was at 18%, and then now it lowered to 17. I think it's at 16 right now. So Atomic Wallet's a good wallet. I like it. It's worked for me so far. You can also stake here on Zillion. I did download the Zillit.io, and I set up a new wallet. It's real easy to set up. You can also stake on this wallet, so I might move some of my Zilliqa over here. And right now as well, the new GZIL has come out, and the GZIL will be a governance token, and there's a limited amount of those tokens, and they're gonna be only issuing those tokens for a short time, and I believe it's every 1,000 ZIL tokens that you earn from staking, you'll get one GZIL token. So be sure to stake as much as you can so you can get as much of those GZIL tokens. I think they're going to be worth quite a bit. Where did I just do? Okay, sorry. Yeah, there's the Zilliqa governance token. This is the Zilliqa Explorer, kind of like Etherscan, and it kind of operates under the same principle. So that's pretty cool. I mean, it has the whole ecosystem there, and there's a bunch of other applications built on Zilliqa right now, and they're just becoming more and more each day. Let's see here, unstoppable domains. If you're not familiar with unstoppable domains, oops, I said upstoppable. If you're not familiar with unstoppable domains, I definitely recommend you go. I'm squatting on about 7 domains right now. Remember when the internet first came about and they had pets.com and coffee.com and sex.com and everything.com, and people were just scrambling around because somebody made it possible to change your IP address from numbers like 192. Blah 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 to a domain name, like eurekastreet.com, and people were buying up those domain names and squatting on them. And I believe angel.com was who is it? I can't remember. That was MicroStrategy's guy, Michael Saylor, bought that, I believe, and then ended up selling it for billions of dollars. If I'm correct, I don't know. I could be wrong. And but Unstoppable Domains allows you to do this with .crypto and .zil, and this is all made on the Zilliqa platform. So this is a really good use case of Eureka. Okay, let's see here. We'll search. Yeah, so Eureka.zil right here. Based on the Zilliqa platform in Eureka.crypto, I don't have these. I wish I could get those, but I would have to pay a premium and try to bid for it. And I don't have enough money to do anything like that right now. But there's other things like Zillionaires. You can play the Zilliqa lottery here. We have the Zil Hive if you want to become involved in their community. And there's newsletters here about a lot of stuff coming out. Travala has partnered with Zilliqa, and Travala is kind of a blockchain based type of travel network like Expedia type of thing. And let's see what else we got here. Zillocracy. It's a basically a community type of platform. I don't really know much about it, but I'll look further into this. But it's a way you can get involved in the Zilliqa community. So there's a lot of stuff going on with Zilliqa right now. It's really interesting. Here's a good article on Byzantine fault tolerance on the geeksforgeeks.org and the practical Byzantine fault tolerance. So I keep saying Byzantine fault tolerance, but there's a specific version of it called practical Byzantine fault tolerance that applies to blockchain technology here. And again, it talks about the whole Byzantine general problem and the army camped out and how did they route messages and knowing which message is the right one to establish identity for security. But yeah, those are ways that you can get involved. I am also mining Zilliqa. I don't have it turned on right this second. I'm actually just mining Ethereum right now, but you can go to 2miners.com and you can dual mine Ethereum and Zilliqa, or you could just mine Zilliqa on shardpool.io. And let's see here. So you can start mining on Shardpool, or you can stake on Shardpool. So you don't have to go to Atomic Wallet or Trust Wallet, or you can stake through Shardpool. You can stake through your Zilliqa.io.wallet. There's a lot of different ways you can stake. And it goes through some pretty simple instructions on how to configure your miner. Honestly, I don't know how I configured my miner. I went through and did it. Let me open something up here and I will show you shardpool.txt. And I will add this in here. Browser. Okay. And okay. Whoops. Oh, never mind. Yes. All right. Well, I was going to show you the code, but it's really not that important. But it's not hard to do. You just download the from 2miners the software onto your computer. You do have to have a fairly powerful computer to do so, and so it does take up some energy, but not as much energy as if you're trying to mine other coins. So it's not going to be like trying to run a small city like Bitcoin or a small country. I mean. Yeah, the mining for Zilliqa right now doesn't really give you a whole lot of rewards right now, but I think that'll grow in value the larger that Zilliqa gets, which is why at this point I'm just allocating my resources over to just mine Ethereum right now. And this 2miners is great. You can mine a lot of different tokens with 2miners. So yeah, look into 2miners. I was on the Claymore mining pool and the mining software, Claymore mining software, but I switched over to 2miners because Claymore no longer does Ethereum after December 29th. I think the developer for this, the anonymous developer for Claymore, kind of shaded out. So yeah, anyway, that's basically my overview on Zilliqa. It's a good project. Right now, Zilliqa is kind of having an issue with a lot of their nodes that were not doing not doing their updates in time, and it's caused an issue with Binance, I believe KuCoin, and several other exchanges, in which I have a transaction that I traded one ERC token to Zilliqa via SimpleSwap. Right here, here's simpleswap.io. It's a really great platform to do changes, and this is a way you can buy Zilliqa. But SimpleSwap went through Binance in order to do the swap, and Binance, I guess, has not updated their nodes. And so I was getting this, I'm still getting this screen, and it's been about 5 days since I've tried to make this transaction, and I have a good bag of Zilliqa that I want to stake that is not showing up in my Atomic wallet, that I can't get my staking rewards on because it's not in my wallet, and hopefully I didn't lose the whole bag and all of my money on that. I mean, it's not a ton of money, but it's a lot of money to me. But what's showing up is nonce is higher than expected, and then per Ethereum rules, what nonce is higher than expected means is transactions with too high a nonce get placed in the transaction pool queue, And then if transactions with nonces that fill the gap between the last valid nonce and the two high nonce are sent, and the nonce sequence is complete, all the transactions in the sequence will get processed and mined. So what this means is my transaction will eventually go through once they update their nodes. My criticism on Zilliqa is, one, the Telegram admins were really condescending, basically saying, Binance literally posted that they're updating their nodes. Okay, yeah, we know that, but they're not. Binance or none of these exchanges are answering regular people like me. So can the Zilliqa team please go on our behalf and fight for us to try to get this situation rectified? Because a lot of people have their money stuck on Binance and KuCoin and these other exchanges by them not updating their Zilliqa nodes in time. So what I think Zilliqa should do in the future is slash these nodes if they don't update them in time, or some kind of penalty, because this is, I could be staking my bag of Zilliqa right now that's stuck on this exchange, and I could be add it to my staking, and I could be making rewards this week. And I know there's a lot of people with a lot more Zilliqa stuck in there than me that could be making a lot of money right now, and they're not. So that's my criticism on it, and those are just easy fixes. Overall, I think this is a really good project, and not financial advice, but I'm adding to my bag, and I'm staking and I'm mining Zilliqa. I think it would be great if you did too, and then we could all help this project grow together. The CEO, let's take a look at the team here. Let's go back to the Zilliqa website, company, about us. And this guy, Amrit Kumar, I listened to an interview on Spotify that had him on there. I guess this was last February, and he talked about the Zilliqa project. And there's a lot of good stuff going on, and I didn't really understand what he was talking about last February because I was fairly new to a lot of this stuff, and I certainly didn't really understand what sharding was. But I've been learning as I go along, and I listened to it again recently, and pretty much everything that he discussed, they've pulled through with and come through. So it is a solid, legit project. So I would highly recommend looking through the project. Their FAQ portion on their website is really good as well. So yeah, go to their website, Zilliqa.com. It's a Zilliqa.com, and take a look. Zilliqa, I guess the company was based in Silicon Valley, and Silicon and Zilliqa kind of sound the same. There's no real amazing story behind the name of it, but yeah, there you go. Anyway, that's my synopsis on Zilliqa for now. It's 42 minutes long so far, so I will let you go. I hope this video was informational or entertaining at the very least. And let's try to spread the word about it, get involved, and hit my thumbs up if you like this video. Subscribe to me, it helps my algorithm. If you like these projects and what I'm doing, yeah, man, just follow me, give me feedback, hit my Twitter up down here in the right corner, and let me know that things that I could do better, or things that you want me to talk about. Just talk to me. I like making friends and talking about crypto. All right, well, I will talk to you guys later, and you have a great January 2nd, and keep watching that Bitcoin go through the roof. All right, bye.